The graph for part B, same thing I'm going to do again is factor things out. So this has a 4x in common. That leaves me with x plus 2, which is what I have in the denominator. Okay, so I know that this is going to be a whole, okay, and there's no asymptote. So let's look at the domain. I have a domain issue at -2, so x cannot be -2. Horizontal asymptotes, if I look at this thing, the exponent on the top is larger than the exponent on the bottom, so that tells me that there's not a horizontal asymptote, so none. So we got to look at the end behavior. So remember we said we could look at end behavior in terms of maybe a limit. So look at what would be happening on the top. So if I plugged in infinity, this is going to get larger and larger and larger and larger because I've squared infinity and then I'm going to multiply by 4. On the bottom, I'm going to take infinity and I'm going to add 2. So I've got infinity, I've got a positive over a positive number. So that means this function goes to infinity on the right, okay? If I plugged in negative infinity and I squared it, I'm going to get a positive. Let me write this in limit notation. So therefore, the limit as x goes to, I plugged in infinity of g of x is infinity. So it goes to the right. If I do the other one, if I plug in negative infinity and square it, I get a positive infinity, so that's a positive number. But if I put negative infinity in the denominator, I get a negative, and a positive over a negative is a negative. So therefore, the limit when I plugged in negative infinity, so as I go to the left of the function, is negative infinity, okay? So on the right, it's going to positive infinity, and on the left, it's going to negative infinity. Okay, we can do that. All right, so next thing is x-intercept. The x-intercept is anywhere that the top equals 0 that is not the whole, so that's this piece. So the top would equal 0 if x is 0. So there's an x-intercept at x equals 0. The y-intercept is when I plug 0 in for all of the x's. Well, if I plug 0 in for the x's on the top, that means I'm going to get 0 times 2, which is 0, over 2, which is 0. So the y-intercept is the same as the x-intercept. Symmetry, if I plug in negative x, I get 4 times negative x squared plus 8 times negative x, and the bottom is negative x plus 2. So on the top, I get one that stays the same, one that changes, and on the bottom I have one that changes and one that stay the same. So this is no symmetry, because it's a neither. All right, and the discontinuities, I have a whole at x equals -2, but there's no asymptote because there's not another factor on the bottom that doesn't cancel out with anything on the top. All right, so let's graph this guy. Okay, so let's graph him. Okay, so at -2, I know I have a whole. I know the x-intercept is at 0 and the y-intercept is at 0, so that's the same thing. I know that it's not symmetric. I know that it doesn't exist at -2 because there's a whole. And I know that as we go to infinity, it's going to infinity. And as it's going to negative infinity, it's going to negative infinity. But look what's going to happen and what's going to help me graph this. These two terms actually will cancel out. So that just leaves me with 4x. 4x graphs like a line. So that tells me that this is also going to graph like a line, but with a whole at -2. So I'm going to go ahead and graph this like a line, but at -2, I'm going to put a whole. And you can check that on the calculator, but they should graph exactly the same as the function would if you canceled them out, as long as there's a whole.